Hey there, physics enthusiasts. Welcome back to the channel. Today, we'll explore one of the most fundamental concepts in physics, rest and motion. In this video, we'll break down what rest and motion mean, how they relate to each other, and how we can classify them into different branches. Plus, we'll take a closer look at the idea of absolute rest and absolute motion, two key concepts that have puzzled scientists for centuries. So, let's get started. Let's begin with the basics. So, what exactly is rest and what is motion? In simple terms, rest means that an object is not changing its position relative to a certain point. It's stationary. For example, a book lying on your desk is at rest because it isn't moving relative to the desk or to you. On the other hand, motion is when an object changes its position relative to a certain point. Think of a car driving down the street. As it moves, its position changes constantly relative to the surroundings. The key idea here is that motion and rest are not absolute concepts. They are always relative to a chosen reference point. Now that we understand the basic definitions, let's dive deeper into the types of motion. There are several ways to categorize motion, and here are a few. Translatory motion, when an object moves in a straight line or along a curved path, like a car moving along a road. The object moves from one point to another. Rotational motion, this happens when an object rotates around a fixed point or axis, like a spinning top or the Earth spinning on its axis. Oscillatory motion, objects that move back and forth, like a pendulum or a swing. Random motion, objects that move in a chaotic and unpredictable way, like molecules of air in a room. Now, let's talk about absolute rest and absolute motion. These concepts might sound a bit tricky, but I'll make it simple for you. In theory, absolute rest means an object is completely stationary, not moving relative to any point in the universe. But in reality, we never really experience absolute rest. Why? Because everything in the universe is constantly moving, even the Earth itself. For example, while you might think you're at rest sitting on your chair, you're actually moving because the Earth is rotating, and the Earth is also orbiting around the Sun, which is in turn moving through the galaxy. Similarly, absolute motion would mean an object is moving with respect to an absolute reference point. But just like rest, there's no such thing as absolute motion either. All motion is relative. So, in essence, absolute rest and absolute motion are idealized concepts, but they don't actually exist in the real world. Now, let's talk about the most important idea in the world of rest and motion, relative motion. Relative motion means that the motion of an object is always measured relative to another object. For instance, if you're in a car moving at 60 miles per hour and you throw a ball in the air, the ball will seem to rise straight up and fall back down from your perspective inside the car. But to someone standing outside, they will see the ball move forward along with the car, as the car is moving. In other words, motion is not absolute. It depends on the frame of reference you choose. Whether you're sitting still or moving at a fast speed, your motion is always relative to something else. Let's take a look at a couple of real-life examples of rest and motion to help you understand better. The Earth's motion. The Earth itself is never at rest. It's always in motion, rotating on its axis, revolving around the Sun, and even moving with the galaxy. So, technically, nothing is ever at rest. Passenger in a moving train. Imagine you're sitting in a moving train. From your perspective inside the train, everything around you is at rest. But to someone standing outside the train, you and everything inside the train are moving. This is relative motion at its best. So, why is understanding rest and motion so important? Well, rest and motion are the foundation of many fundamental concepts in physics. Understanding these concepts helps us study the laws of motion, like Newton's laws, and is essential for understanding things like velocity, acceleration, and force. These concepts help us explain how everything moves in the world, from a car driving down the road to planets moving in space. Without understanding motion, we wouldn't be able to design machines, spacecraft, or even understand the simple act of walking. And that's a wrap on today's deep dive into rest and motion. We've learned how these fundamental concepts shape everything around us, from simple objects to the grand scale of the universe. Remember, motion is always relative, and while we may never experience absolute rest or motion, understanding how motion works in our everyday lives is crucial to understanding the world we live in. If you enjoyed this video and want to learn more about the exciting world of physics, make sure to like, subscribe, and share this video with your friends. Stay tuned for more amazing science videos and keep exploring the world of motion.